Welcome back all the way from Amsterdam. In the previous lesson, we learned how to use the limit definition of derivatives. Well, today, we're going to learn the 3 rules of continuity. Well, let's get started. In order to tell if a function is continuous, you check the 3 rules of continuity. The first rule is f of a defined? The second rule is the limit is f of x as x approaches a exists. The limit of f of x as x approaches a from the left-hand side should equal the limit as x approaches a from the right-hand side of f of x. And the third rule is, does the limit of f of x as x approaches a equal f of a? For example, y equals x squared from 0 to 2, 6 minus x from 2 to 5, and 7 at x equals 2. Now graphically, what does this look like? So first, let's think about the x squared. So x squared goes from 0 to 2, but does not include the 2. So from 0 to 2, but since it does not include the 2, we're going to use an open circle. And then we need to graph 6 minus x from 2 to 5. So that function will look like this. So let's say this is 2. And this is 5. This does not include the 2 as well, so it will be an open circle. And then this part, at x equals 2, y equals 7. So it's a closed circle. So this is 7. So in order to check if this function is continuous at x equals 2, we need to first check if f of 2 is defined. So, what does f of 2 equal? If we look at our function at 2, we know that it equals 7 based off of this function. Now, our second rule, we need to check if the limit of f of x exists by looking at x as it approaches a from the left-hand side and the limit of f of x as x approaches a from the right-hand side. Now, what does that mean? If we look at the limit as x approaches a, which is 2 from the left, so we're going from the left to the right. So the left to the right is this function right here. So we plug in our a value, which is 2. So 2 squared, and we're checking if it equals the limit of f of x as x approaches a from the right. So it's from the right towards the left. So you start on the right towards the left, which is this function right here. So we plug in 2 to this function. So we have 6 minus 2. So 2 squared equals 4 equals 4. So the limit of f of x as x approaches a equals 4. Now our third and final check is, does the limit of f of x as x approaches a equal f of a? Well, here we determine the limit of f of x as x approaches a, and we got 4, and it should equal f of a. This first part is where we determine f of a, and we got 7. So 4 does not equal 7. So we would say this function is not continuous at 2. As we see, it's a jump. It should be 4, but it jumps up to 7 and comes back down.